All right, students, I got another question. I'll try to answer here, number 48. Oh, and this is that two-dimensional one that I was doing near the end of class here. But it says two objects, one is moving north and the other is moving east. They collide and stick together. All right, so this is, again, an interaction, a collision. So I'm going to use the idea of conservation of momentum. And it's a two-dimensional one because it says one is moving north and the other one is moving east. So maybe the one going north, I will say, has a momentum that looks like that. Won't give it a little number, I'll just give it a direction. And the one that is heading east has a momentum this way. And so remember, we have conservation of momentum. Conservation of momentum not only in the x, but also in the y. And so this was my comment that just like we did chapter 4, we did two-dimensional motions by doing one-dimensional motion twice. Here we have a collision, we have an interaction, and we're going to do our conservation of momentum, and we're going to do it both for x and for y. Okay? Now here it says, let's get some numbers in here. Here it says, because, by the way, I drew these, but I don't know how big they are here. So let's talk about some numbers. If the eastbound, so this one object, has twice the mass as the initial moving, half as fast as the north one. Okay, so let me put some symbols here. So if I say the north one has a mass of m and a speed of v, all right. So we'll call this the north one, mv. Then over here, it says if the eastbound object has twice the mass, so 2m, and is initially moving half as fast, so 1/2 v. Okay, so this right here is the mass of the eastbound one, and this is the speed of the eastbound one. But notice that the 2's would cancel off and you would get mv, which is the same momentum as that. So they don't give me a number to work with, but they give me some kind of comparison to them. And so if this is the momentum of the northbound, this is the momentum of the eastbound, and they're the same. So kind of in this picture, I'm going to say, okay, I have this much momentum going north, and so I'll try to draw an arrow that is, I'll call it a centimeter. It looks like it's a little more than a centimeter. But to match it, the eastbound one would have exactly the same length. So forgive my picture if they don't look exactly the same length, but that's what I'm trying to do. So I'm going to tell you, I'm trying to draw them. So I have momentum both up and momentum both right. Same amount. So the total then doesn't change. So after the collision, I would have the same amount going east, and, I didn't give myself enough room, and the same amount going north. Okay? So the momentum total would be to add these two together. And so this is what we're kind of learning here this semester, is to think about direction when we add things, not just the numbers and not just the units, but also the direction. And that's new. I keep saying that's something we didn't really do in a math class. In math class, you learned a lot about numbers, once in a while units. In a science class, you learned a little bit more about units, but direction, maybe not so much. Maybe a little bit, but maybe only in a physics science class, so maybe a high school, maybe even a middle school, but these arrowheads are important to think about. Anyways, so because I have an equal amount up and an equal amount right, it would be some kind of angle like this, 45 degrees. That's what 45 degrees is. Equal on the horizontal leg and equal on the vertical leg. So when we look at this and say what path is it going to have, it's going to have to go like this, the direction of the momentum. The two have to go in that direction. And so of our three options, C would be the direction. D would be the direction if you had more horizontal momentum than vertical. And B would be the answer if you had more vertical momentum than horizontal. And A and E would even work for this problem because A is straight up. So only if you had upward momentum would it be A. So both of these would have to have upward momentum. upward or downward. Like we could have plus or minus, but and then E would only work if we had all horizontal momentums, left and right. So the option is C. Yeah, hope that helped.